Oh, we're going to have a lesson here on the properties of real numbers. Our objectives today are to graph and order real numbers, and then we want to be able to identify properties of real numbers. In order to do those two things, though, first we need to be able to categorize the real numbers into groups. So I've got a list of real sets down here. I got natural numbers, whole numbers, integers, rational numbers, and irrational numbers, and we're going to jot down what those are in a second. Before we do that, looking up above there, I'm posing a question. If I asked you to the nearest hour, how many hours of sleep did you get last night? There are certain things you couldn't give me for an answer, and I said negative numbers wouldn't be a good answer. Negative numbers would not be in the domain of the question. Domain is a word that we're going to use a lot this year. Domain is the numbers that you can plug into a problem. Domain is the numbers that you can use to represent a certain situation. And here, negative numbers wouldn't work. You know, if you gave me an answer of I slept -1 hours last night, I would think you didn't get a very good night's sleep, but it wouldn't make any sense what you said. So, what do we have here? We've got natural numbers. What does the word natural mean? To me, natural means what comes to you without really thinking. You know, if you're a natural baseball player, you can hit a ball without a lot of practice. So, natural numbers, what comes to me without thinking? Well, when I was a little guy, the first thing that came to mind, I guess, was the number 1, and that is the first natural number. And the natural numbers kind of just continue from that. They go 1, 2, 3, 4, and just continue on like that. That is a subset of real numbers known as the natural numbers. The next set of numbers is the whole numbers, and the whole numbers really aren't that much different than natural numbers. The whole numbers start with a whole. They actually just are the natural numbers, only they start with a whole. The number is 0, which looks like a whole. So here's our whole numbers. Dot, dot, dot means go on forever and ever and ever. Integers are whole numbers, but now we can actually include the negatives in there. So integers not only are 0, 1, 2, 3, 4, but they are dot, 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 meaning go forever left. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Rational numbers. Well, what do I think of when I see the word rational? I always see rational as having the word ratio in it. And to me, ratio means fraction, and that's what rational numbers are. They're any number that can be written as a fraction. Now, this is a little tricky because, you know, I can put a number like 2/3 and go, well, that's obviously a fraction. But I could also put, say, the number 4, and that's a rational number as well because I could write that as the fraction 4/1. So any number that can be written as a fraction is a rational number. We'll finish her off now then. So if rational numbers can be written as fractions, then irrational numbers can't be written as fractions. And what numbers can't be written as fractions? Well, you guys have come across some over the years. That's probably the most common one, pi, which hopefully remembers 3.14, and it goes on forever and ever and ever and ever. Another one we'll talk about this year is the letter E, which is like pi. It's a number that's 2.718, and that goes on forever and ever and ever. And they don't repeat, by the way. If they could be repeating, then you could write them as a fraction. And then finally, the one that we usually miss are square roots that don't change into whole numbers. Like the square root of 2, there isn't any number that you multiply by itself to get 2 that terminates. You know, so if I square root 2, I'm going to get 1 point, something that goes on forever and ever and ever and never repeats. So that's another irrational number. So here's our 5 sets of numbers that are within the real numbers. There are numbers that aren't real, and that will be some fun that we save for later on in the year. So, which set best describes the amount of sleep you got last night to the nearest hour? Well, hopefully for most of you that would be the natural numbers, but I guess, you know, some of you wild folks there, or maybe you're just insomniacs, maybe you didn't get any sleep, so I guess you could argue it could be the whole numbers, or certainly natural numbers, because you're rounding to the nearest. So they are also rational numbers, but I wouldn't use rational numbers because if you gave me any fraction, like if it's 2/3, that's not a possible answer. So, and they're also integers, but they can't be negative, so I can't use that group either. So I would accept either natural or whole numbers. Now, what do I want you to do with this box right here is if you understand what I've been talking about, and you're like, okay, no problem, I understand it's either whole numbers or natural numbers. If you actually got some sleep, I go either one of those. Then what I want you to do is go ahead and put 4 here. Feel real strongly 4. Put a 3 if you feel a little hazy, or you can see where I might be able to trip you up into a question like this. You just don't quite get. Put a 2 if, I think I need another problem, not quite understanding, and put a 1 if you just have no clue. If you think I'm talking gibberish at this point, put a 1 there so we make sure and go back and look that over before we take any kind of exam on it. Okay, let's try to move down the way here. The opposite reciprocal of an integer is what type of number? The opposite reciprocal of an integer is what type of number? I guess I would pick an integer because it says, of an integer. So I'll pick any integer. I guess 4 is an integer. And now if I take the opposite reciprocal of that, 4 is going to turn into opposite reciprocal. Well, opposite of 4 is -4. And then what does reciprocal mean? It means that you flip it over. So then flip to -1/4. Okay, so what kind of number is -1/4? Well, it's obviously a fraction, it's negative. What numbers are fractions? Rational numbers. That looks like that would be a rational number. Is there any, so that would be my answer here. Rational numbers. Is there anything that would cause a problem in this situation? Now, is there anything that I couldn't look at right here in my integers? Is there anything in the domain of integers that would cause a problem? So here I use 4. I said, well, 4 is an integer, that's the domain of my problem. It turned into -1/4. Is there anything that would cause a problem? Well, if you're really thinking, what if I would have started with 0? Then you make it -0, which that doesn't make any sense. There's no such thing as -0. Then you would flip and be 1 over -0, and hopefully you know that 1 or anything over 0 is undefined. That's just not cool. You can't have that. So actually, the answer to this question would be rational numbers as long as the integer isn't 0. I wouldn't expect you guys to necessarily get that, but I want to see give you the type of thinking that you have to be careful of when you're trying to answer a question like this. So let's, again, you got your 1 through 4 over here. 4, hey, that's no problem. I could explain this to my buddy. 3, I got it. Don't necessarily want to explain it because I might make a little mistake. 2, need a little bit more work. 1, you lost me. So when we do a 1, make sure you're asking questions coming in for some help so we can address that issue. Okay, example 2. Graph the two numbers on a number line, compare them with inequality symbols. When I say inequality symbols, that are either this or this, and hopefully remember what those are. They kind of look like L's, so these are your less than symbols. You got less than or equal to, and then either this or this. These are your greater than symbols. So we want to put a symbol in between the square root of 8 and 11/4, one of those 4 symbols. Obviously, you could use a couple of them because you could switch the order of them. But if the 8 was on the left, if you left square root of 8 on the left, I would only use one of them. So how do you compare these? I guess I just plug it in a calculator. Now, I do want you to understand that square root of 8 has to be a little less than 3 because the square root of 9 is 3. So square root of 8 is a little less than 3. The question is, what is it? It's going to be 2 point something. Now 11/4, I think of that as 2 3/4. Because 11 divided by 4, 4 goes in there twice, and there'd be a remainder of 3, which that is 2.75. So I guess the big question is, when I square root 8, do I get something that's bigger than 2.75 or less than 2.75? So what I would do is go ahead and plug that into my calculator, see what that is, and type that in here, square root 8, and I get 2.83. So square root 8 is bigger than 11/4. So what would I be looking for here? Oh, maybe something like this. They're both between 2 and 3. 11/4 is between 2 1/2, which would be here, and 3. So right here. And I'll put a dot there, and I'll call that 11/4. And then the square root 8 is just a little bit to the right of that, so I'll put a different dot there and square root 8. And that's what we're looking for in the number line. Not a huge deal there. If I was going to put it in equality, I would write 11/4 on the left, square root 8 on the right, and then I would go ahead and put a less than symbol there because 11/4 is less than square root 8. I always have your arrow pointing at the smaller number. You know, it's not like to point, you want to point at someone smaller than you, but if you can envision that would, don't point at someone if they're bigger than you for sure. That could be bad. So, but point at the smaller one, try to keep that in mind. Again, that looks like an L that way, and always keep the less than, the smaller number on the left. And continuing on, last thing we need to do is go over some common properties of addition and multiplication. I'm just going to go ahead and scroll down on these. The real important ones that you can see come up on, say, an MCA or ACT test, they might refer to the commutative. And when I think of commutative, I think of the word commute, which if you talk to your parents and they work in the cities, that's what the commute is. They drive down to work, and then they drive home from work, and it's the same distance. And can be equally painful for your parents. So all that's what this is saying. A plus B is the same as B plus A. Going from work to home is the same as going from work to home to work, or home to work, work to home, either way. And that works for both addition and multiplication. Associative, another important property. All associative does is it has 3 elements, A, B, C, and they stay in the same exact order. The parentheses move. So here A, B, C, A, B is on the left. Here A, B is still on the left. It's just the parentheses move. So that's the way to tell the difference between commutative and associative. Associative, the parentheses move. Commutative, the elements actually switch around. Identity, well, it's kind of important to know that. If I talked about addition identity, identity with addition, well, it's called an additive identity. If I asked you, what's the additive identity? Well, hopefully, to keep your identity means to stay the same. So if I add, what number keeps the number the same? What can I add so the number stays the same? 0. How about multiply? What's the multiplicative identity? What can I multiply by so a number stays the same? Well, hopefully you know that would be 1. And there you see the patterns for additive identity and multiplicative identity. If you take a number and add 0, you get the number. If you take a number and multiply it with 1, you get the number. Inverse. For addition, inverses are just opposites. I want to write the word opposites next to this somewhere. And for multiplication, they're reciprocals. On the previous page, I asked you to do the opposite, which was turned into a negative, and reciprocal, which would flip it over. Those are both inverses. Opposite and reciprocal are both inverses. Just one is for addition, one's for multiplication. And then finally, the distributive property most people are pretty cool with here. You guys use that a lot. Got a number outside parentheses. You just go ahead and multiply that by each term on the inside, and you get your new result. So those are very important properties. Commutative, associative, and distributive. Those are the ones that are going to come up the most. Those are the ones that are referred to later on in the year. So try to keep that in mind. All right, so what properties are being shown down here? this one right here, things actually change order. So sometimes you might think, oh, parentheses got switched around, but really what happened was this 5 plus 4, instead of being on the right, went to the left. So it was kind of like A plus B on this side, but over here it was B plus A. Only 5 plus 4 is actually my B. So that is the commutative. Notice there's no N in the word commutative. That's the commutative property of addition. And then finally what happens there on the bottom one, we got 2 times AC and then 2A times C. Nothing changed order. It's 2AC on the left, it's 2AC on the right, but the parentheses moved. When the parentheses move, that's associative prop. And in this case, we're multiplying, so a multiplication. And that's the extent of our 1.2 lesson. Please, if you have any questions after viewing this, see me in my room.